for this problem is work energy. We have a guy pulling a sled with an angle and a mass. You have your coefficient of kinetic friction, displacement, and a constant velocity. And we have, we're trying to look for work, and work is the forces times displacement times cosine of theta. First, you have to start off by drawing a force-based diagram where you know your force is being pulled at an angle, and you have a kinetic friction of it's kinetic because it's moving, it's not stationary. Sum of the force in the x direction is equal to 0 because there's no acceleration, and that's equal to negative kinetic friction plus your forces times cosine theta. That's both two things in your x direction. Kinetic friction can also be known as mu k times n. And your sum of the forces in the y direction is your normal force minus your mass times gravity plus the forces times sine of theta. And that's set up to equal to 0 as well because there's no acceleration. And you can rearrange that to find out what n equals to mg minus f sine of theta. And then you can use that to plug into this formula right here. So mu of k times maximum gravity and mu of k times f sine of theta will get set up to give you this. And then so your mu of k distributes to both of those, and you're left with, you can add this to the other side to get over there, and then you factor out the f from these two, and you're left with that mu of k times sine theta plus cosine theta, and then you can divide that to the side to get forces on. So force is equal to mu of k, mu of k over mu of k, those cancel out, and you're left with the mass times gravity over sine of 20 plus cosine of 20, and your forces is equal to 41.2 newtons. Well, we're trying to look for the force that is done by this guy, and then if you come down here, your work is equal to the forces times displacement times cosine theta. So work is the force needed to pull and times displacement times cosine, and it's at a 20-degree angle, so it is equal to 46.45 joules, and that is the answer.